Good morning, happy Tuesday. Today we'll be doing another lesson.
Welcome, Intro to Calc. Today we're going to do lesson 5.2, part 2, and it's called Rates of Change, and we're going to talk about velocity. So velocity is just how fast you are moving. So if we have average velocity, we're talking about slope. Okay, so V average for average velocity is equal to change of S over change of T, which is the same thing as doing the difference quotient. F of T plus delta T minus F of T over delta T. Okay, and we have talked about just the general slope equation before. What we're going to talk about now is called instantaneous velocity. Instantaneous velocity is when you're going to use the limit. Okay, so instantaneous velocity, we're going to have V of t is equal to ds dt, the derivative, which is equal to the limit as delta t approaches 0 of f of t plus delta t minus f of t all over delta t. And a little bit more of what instantaneous velocity is. So think about a car speedometer. Car speedometer is something that tells you how fast you're going. It's the velocity at one moment in time. All right. So that's a little background knowledge of what these two words mean. So, sorry for all this writing. If we were in class, you'd have nice notes with the word problems already typed out for you. So, example 1. If a billiard ball is dropped from a height of 100 feet. If a billiard ball is dropped from a height of 100 feet, its height S at time t is given by the position function S of t is equal to negative 16 t squared plus 100. All right, so if a billiard ball is dropped from a height of 100 feet, its height S at time t is given by the position function S of t is equal to negative 16 t squared plus 100. Okay, so I'm just going to kind of bubble this because this is probably going to be a little important. It's an equation where S is measured in feet and t is measured in seconds. We need to find the average velocity. I'm going to underline that because we know that that's a key word, over each time interval. All right, so if a billiard ball, which is kind of like a pool ball for those that play pool, from a height of 100 feet, its height S at the time t is given by the position function S of t is equal to negative 16 t squared plus 100. Where S is measured in feet and T is measured in seconds, find the average velocity over each interval. So we have three different problems here. Problem A, we're going to do it over the interval from 1 to 2 seconds. The second one, from 1 to 1.5 seconds. And C, from 1 to 1.1 seconds. And you'll notice each time the interval is getting smaller and smaller. All right, so we're talking about the interval from 1 second to 2 seconds. So these have square brackets, so they're not coordinate points. If this is the time 1 second, we know this 1 represents t. We need to figure out what s is. So if we plugged in the point 1 into our function, negative 16, 1 squared plus 100, we will get 84. When we plug in 2, we're going to get 36. Negative 16, 2 squared plus 100, you get 36. I'm going to go through and find the coordinate points for all of them. We already know 1, 84. So I'm going to write it for both B and C. When we plug 1.5 in, you're going to get 64. And when you plug in 1.1, you're going to get 80.64. Awesome. Since we're finding the average velocity is just slope. So we are solving for the slope between those points that we created. So I'm going to write the slope is equal to change of y over change of x. 84 minus 36 over 1 minus 2. So the slope, negative 48 feet per second. Word problems always need to have a label. Good. The slope for this one, 84 minus 64 over 1 minus 1.5. The slope is equal to negative 40 feet per second. 20 divided by negative 0.5, negative 40 feet per second. And the last one, 84 minus 80.64 over 1 minus 1.1. Your slope is equal to negative 33.6 feet per second. So at those time intervals, those are the average speeds of the billiard ball. Oops. Sweet. So what this is saying, the slope is negative. The slope is negative, meaning the ball is moving downward. Awesome. So we have just figured out how to find average velocity by using the slope formula. Perfect. So the only difficult part here is that we had to actually come up with the coordinate points to use in order to find the slope, because all we were given was the time interval, not a coordinate point of this function. Awesome. Next thing that we're going to really need to remember, I'm going to start our exclamation point. Velocity is the first derivative of position. I'm going to bubble it. Excuse me. All right, awesome. Velocity is the first derivative of position. This is super, super important for us to figure out instantaneous velocity. All right, this is example 2. I have it written down already for myself, but you can pause the video so you can copy it down if you wish. So, at time t is equal to 0, a diver jumps from a platform diving board that is 32 feet above the water. The position of the diver is given by the function s of t is equal to negative 16t squared plus 16t plus 32, where s is measured in feet and t is measured in seconds. So that's just some given back information. So part A is asking, when does the diver hit the water? So if the diver is going to hit the water, the height is going to be 0, or s of t is equal to 0. That's really what this question is asking. When is the diver going to hit the water? When is the height going to be 0? So I'm going to plug 0 in for s of t. So negative 16t squared plus 16t plus 32. We are now solving a quadratic. There are a couple ways to solve a quadratic. One way is to factor. Another way is to use quadratic formula. Another way is completing the square, or you can graph it. This one, luckily for us, is factorable, and I like to factor, so we're going to factor. I noticed 16, negative 16, 16, and 32 are all divisible by negative 16. So I'm going to divide both sides by negative 16. So I'm left with t squared minus minus 2. Now we have to think what multiplies to a negative 2 and add up to a negative 1, a negative 2, and a plus 1. Then when you're solving, set each of these factors equal to 0 and solve. So t is equal to 2 and t is equal to negative 1. But since we're talking about time can't be negative, so we have to throw away the negative 1, and it's going to be after 2 seconds. Awesome. So we know after the diver jumps from a platform, they're going to hit the water in 2 seconds. Good, we answered part A. Part B is when it starts to become a little bit more calculus. Part B says, what is the diver's velocity at impact? Okay. Velocity at impact is asking us to find instantaneous velocity. Remember, velocity is the first derivative of a function. So what we're going to do first, and what is the diver's velocity at impact? We know the impact, we know S is equal to 2 seconds. Because we know it takes the diver 2 seconds to hit the water. So first, since we're finding velocity, instantaneous velocity, we have to find the derivative. So S prime of t. Yesterday, we learned how to do the shortcut. So let me rewrite S of t. Okay. S of t is equal to negative 16t squared plus 16t plus 32. So S prime of t, you're going to take this 2, multiply it out in front, negative 32t, subtract 1 from the exponent, 2 minus 1 is 1. The exponent of this t is a 1, so 16 times 1 is 16. 1 minus 1 is 0. Anything to the power of 0 is nothing. And if you're taking the derivative of a constant, the derivative of a constant is just 0. So we know that now the formula for velocity, S prime of t is equal to negative 32t plus 16. Since we're trying to find the velocity at 2 seconds, we're going to plug 2 in for t. And you're going to get negative 48 feet per second is the velocity of this diver when it hits the water. Awesome job, guys. See you tomorrow.